Hi, in this video, we are going to look at a problem involving straight lines and circles. So let's get started. The question says, let m be the max value of c square for which origin 0, 0 and point A 1, 1 do not lie on opposite sides of the straight line. The straight line equation is a plus b whole square x minus ab plus bc plus ca plus 1 times y plus 2 equals 0. And this is true for all a, b belongs to reals. It is also given that line lx plus my plus n equals 0 is a variable line where lmn are the first, third, and seventh terms of an AP, and the variable line always passes through a fixed point alpha comma beta. Now, the third part of the question says, if the point 2 comma k lies outside the circle, with equation x square plus y square plus x minus 2y plus m minus 17 equals 0, and also outside the circle x square plus y square is equal to alpha square plus beta square. We have to find the minimum positive integral value of k. So the statement of the problem is very long, and there are actually three parts to the problem. This is the first part where it was given that m is the maximum value of c square for which these 2 points lie on the same side of the straight line, right? For all AB belongs to real. The second part of the problem is about a variable line where the coefficients L, M, N are first, third, and seventh terms of an AP, and the variable line always passes through a fixed point. So this is a concept of family of lines. So we have to find that fixed point, only then we'll get alpha comma beta. And the third part of the problem uses that alpha beta value and the fact that the point lies outside the two circles to find the possible values of k. So we have to do it in a step-by-step manner. You should try to do it yourself. Pause the video and try it out yourself. I will attempt it on the next screen. So we'll start with the first thing. Here we know that the points 0, 0 and 1, 1 do not lie on opposite sides. So they must lie on the same side, of the line. And the line equation was given as a plus b whole square x minus ab plus bc plus ca plus 1 times y plus 2 equals 0. So when do 2 points lie on the same side of a line? So if you put the point 0, comma 0 in this line equation, you are getting plus 2, which is positive. And if 1, comma 1 lies on the same side of the line, then when you put 1, comma 1, it should also be positive, right? So you'll put 1, comma 1, you'll get a plus b whole squared minus ab minus bc minus ca minus 1 plus 2 should be greater than 0, right? So we are getting this condition. Now to think about this condition, let's simplify it a little bit. We can get a square plus 2ab minus ab, so plus ab plus b square minus bc minus ca plus 1 greater than 0. And we can make this equation, which is true for all ab belongs to real, we can make this equation a quadratic in A. So we can say a square plus a common b minus c plus b square minus bc plus 1 is greater than 0 for all ab which are real numbers. So the only way this will happen is if the discriminant here is less than 0, right? So the discriminant here is less than equal to 0 for this to happen. And so the discriminant, if you calculate, it comes out as b minus c whole square minus 4 times b square minus bc plus 1 is less than 0. Why does the discriminant have to be less than 0? Because the quadratic will be above 0 only if it doesn't have any real roots, right? So we have this equation now. If you simplify this equation, we will get basically b square plus c square minus 2bc minus 4b square plus 4bc minus 4 is less than 0. From here we get minus 3b square plus c square plus 2bc minus 4 is less than 0. And make it a quadratic in b. So you will get 3b square plus 2bc. We can change the sign. So I have changed the sign, multiplied by minus 1. I get 3b square minus 2bc plus 4 minus c square must be greater than 0. And this condition also is true for all a and b real. So all b, this condition has to be true. So this is a quadratic in b now. And for the quadratic to be always positive, the discriminant of this quadratic should also be less than 0, right? So we are applying the same concept twice. The discriminant of this quadratic, I will write here, is coming up to be 4c square minus 4 into 3, so 12 into 4 minus c square is less than equal to 0, right? So basically we are getting this situation as c square minus 12 plus 3c square is less than equal to 0, and you're getting c square is less than equal to 3 from here. So c square is less than equal to 3 is coming as the condition for the 2 points 0, 0 and 1, 1 to lie on the same side of the line. Now in the question they had said, let m be the max value of c square for which this is true. So the max value of c square is clearly 3, right? So m comes out to be 3 for us. So that concludes the first part of the problem. By applying theory of quadratic equations and looking at this general expression and writing it as a quadratic first in A and then in B, and in both cases we are saying discriminant should be less than equal to 0. We are getting the condition that c squared is less than equal to 3 and therefore m is equal to 3. Now we go to the second part of the problem. Here we had a variable line lx plus my plus n equals 0, which always passes through a fixed point alpha beta. And L was the first, M was the third, and N was the seventh term of an AP. Right? So L can be written as L itself because it's the first term, but M can be written as L plus 2D, and N can be written as L plus 6D. So therefore, this line equation can be written as Lx plus L plus 2dy plus L plus 6d equals 0. So here, if I want to express it as an equation of a family of lines, I need to separate the equations and write it as the combination of two separate equations. So we can write it like this: 2dy plus 6d equals 0. We can say L comma x plus y plus 1 plus 2d comma y plus 3 equals 0. So now think about it. This is an equation of two lines, L1 plus lambda L2 equals 0. L1 is the line x plus y plus 1, L2 is the line y plus 3 equals 0. So this is a family of lines equation, and it will always pass through the intersection of L1 intersection L2. So you can intersect x plus y plus 1 equals 0 and y is equal to minus 3. And the intersection here will become basically y is minus 3. So x is equal to 2 comes, right? So the point that always is on this family of lines is the point 2 comma minus 3. That becomes your alpha and beta, right? Now we have gotten our alpha beta. We have also gotten m value as 3. And now we are ready to solve the final part of the problem, right? So this was a concept of family of lines. You should be familiar with that if you have done straight lines. Okay, let's go to the final part of the problem. The question said 2 comma k lies outside both the circles, and the circle equations were x square plus y square plus x minus 2y plus m minus 17, but m is 3, so it is minus 14 equals 0. And x square plus y square is equal to alpha square plus beta square. Alpha is 2, beta is minus 3, so it is 4 plus 9, so 13. So the point is outside both the circles. So that means when you put the point into the circle equation, you will end up with a positive value. So let's do that. You get 4 plus k square plus 2 minus 2k minus 14 is greater than 0. So this gives k square minus 2k minus 8 is greater than 0. So this can be factorized as k minus 4, k plus 2 is greater than 0. So from here we are getting k belongs to minus infinity to minus 2 union 4 to infinity, right? And from here we are getting 2 comma k. So 4 plus k square minus 13 is greater than 0. So k square minus 9 is greater than 0 and k square is greater than 9. So k belongs to minus infinity to minus 3 union 3 to infinity here. And now we have to take the intersection of both of these conditions. So the final value of k will range from minus infinity to minus 3 union 4 to infinity, right? This is the final range of k. So if you want the minimum positive integral value of k, it starts from above 4, but 4 is not included. So the lowest positive integral value of k is 5. And that is the solution to your question. So the point is, a lot of concepts were used here, some straight line concepts, then family of lines concept. Also, we had to work through quadratic equations, discriminant less than 0 twice. And finally, there were two circles and we wanted to find a point which is exterior to both of the circles, right? So ultimately, the problem involved multiple concepts in coordinate geometry, and that's why I wanted to show you this one. So hopefully you have gotten something from this video. If you like the videos, please subscribe to the channel and like the videos and share it with your friends and all. I'll see you next time.